Seeking English, S.A.T. Workbook, page 418, problem 1, no calculator. Out of every 7 pitches that a pitcher throws, 4 are strikes. If during the season the pitcher throws 2,800 pitches, how many of his pitches are strikes? Possible answers are 1,200, 1,400, 1,600, and 2,100. Many students can do this one quickly in their heads. That's nice. A person of my age and experience often can do that. But it is not my job to show you how I or somebody else does something in their head. I want to show you what the correct graphic process is, or what one of the possible correct graphic processes is to get the correct answer quickly and accurately. Most of my students are in Latin America, depending on how you define Latin America, and they have all been taught something called the rule of 3, which, if it was taught to me, it was not called that. And I'm still not sure what they were taught, but it seems to work for them. If it works for you, then go ahead and use that. Otherwise, I'm gonna show you what I use and what works for me. And if it looks or does not look like the rule of 3, either way, that's fine. This is the procedure I recommend. Okay. It says that 4 out of 7 pitches are strikes. So that is the part over the total. And this fraction is, you may think of it as a ratio, but again, I want to emphasize the difference between different types of fractional expressions or ratios. This is not a ratio between a part and another part. This is a ratio between a part and the whole. If the whole is equivalent to 7, the part is equivalent to 4. The other part would be 3. So it's not 4 to 3, 3 to 4. It's 4 to 7. Am I explaining it again? Yes, I'm explaining it again. Why? Because somebody's still getting it wrong. Maybe not you, somebody's still getting it wrong. Okay. So that's your model fraction. Okay. And on the other side, you have, in the denominator, we have this 2,800. Okay. So that's the real number of pitches. Okay. That's the abstract number of pitches. Over here is going to be the real number of pitches, which is the unknown, and that is the abstract number of pitches. And these things have to be equivalent somehow. Okay. So a couple ways to look at it is figure out how to scale up 7 to 2,800 and do the same thing here. My instinct, though, is to take this straight over here. So if nothing else goes perfectly, I at least have x all by itself right away. Okay. 2,800 times 4, and yeah, I will show you again. An invisible denominator of 1 is formed. Okay. Yeah. Just to help you visualize that. Because I find it helpful, you may find it helpful to routinely visualize it. Okay, that's the x there. Now you have all the numerical data on one side and the unknown on the other side. And you notice the problem didn't tell you to call it x. It just said, what is it? There's no reason you can't call it x. That's a good thing to call it. Over here you have you have to simplify this. My suggestion in simplifying this would be to get rid of the 7. Since it is compatible with one of the things on the top there. How is it compatible? The 7 and the 28 combine in this way. If you take 7 out from here, you divide this by 7 and you divide this by 7. The 4 can stay the same, and this becomes 1/7 of 2,800, which becomes 400. And then the invisible denominator again goes away. Okay? There. 4 times 400 should be 1,600. Okay, 1,600. And that is answer C. I have not yet determined any specific reason why somebody would get 1,200, 1,400, or 2,100. So if you have any answer there, I don't know. But you notice that I keep pointing this out. The correct answer is either B or C. Okay, really? Is that a real pattern? I will leave that up to you to decide. But in my observation, that is a real pattern, not only in exercise materials, but also on simulators and on real tests. The numbers are in obvious order, like this. The outside answers A and D are less likely because there's less to confuse them with. Okay. So if they want to make it less confusing, there are ways that they can do that by manipulating the answers. But looking at these answers, my suggestion about learning how to do problems like this in your head is to look at that 7 and that 4 and that 28, and then look at your answers. Your answers are all end in 0, 0. Okay? So what's going to distinguish them is not the 0, 0 part, anything that would go in there. You have this relationship between this 4 and this 7, okay, is this 28. And then you have to kind of extrapolate from there. Doing it in your head, the answer, I think, would come out to 1600 if you are just habituated to doing it that way. Okay, I know I'm not explaining it well, but if you look at the numerals that explain the differences between these problems, they often will pop one of the answers out to you as being obvious or being more likely than the others. In this case, the 1600 jumps out at me because of the relationship between the 28, the 7, and the 4. And those 2 zeros there are just sort of there to confuse you. Okay? I don't know if that is helpful at all, but if you can learn to spot things like this more quickly, they may or may not affect your answers, but they can affect your confidence and allow you to move on more quickly. Okay? Once you've got the correct answer, it may look more correct to you if it matches something intuitive. Okay? So yeah, so if you have any reason why 1200, 1400, or 2100 would seem to someone like the correct answer, please do tell me. Thanks.